We are here to help.
In part 1, we discussed the conditions that must be met in order to use the method of undetermined coefficients. We learned how to determine the general particular solution based on f of x, and what to do when the homogeneous and the particular solution have a common term. In this video, we will continue with the method of undetermined coefficients to solve differential equations using the superposition principle. Let's begin with what the superposition principle says. If y1 is a solution to the differential equation with non-homogeneous term f1, and y2 is a solution to the differential equation with non-homogeneous term f2, then for any constants k1 and k2, the solution k1y1 plus k2y2 is a solution to the differential equation with the non-homogeneous term k1f1 plus k2f2. Consider the differential equation a times y double prime plus b times y prime plus c times y equals f of x, where a, b, and c are all constant. Suppose f equals f1 plus f2 up to fn is a sum of functions all belonging to the family of functions under the undetermined coefficients conditions. And suppose that p1 through pn are the corresponding general particular solutions to each function fn. Then p of x, the sum of p1, p2 up to pn, is the general particular solution to the differential equation. Let's see this demonstrated in an example. Consider the example y double prime minus 2y prime minus 3y equals 4x minus 5 plus 6x times e to the 2x. We first solve for the homogeneous solution by solving the characteristic equation, and we get the following homogeneous solution. Now we can focus on the particular solution. As we can see, f of x has more than one term. The first two terms make up the first-degree polynomial function 4x minus 5, and the third term is a product of the polynomial function x and e to the power of 2x. The function 4x minus 5 corresponds to the general particular solution ax plus b, and the function 6x times e to the 2x corresponds to the general particular solution alpha x plus beta times e to the 2x. Now we check if either of these have a term in common with the homogeneous solution. Since they don't, we can move on to the next step. By the superposition principle, the general particular solution to this differential equation will be p1 plus p2. Now we can plug this into the original differential equation and simplify. We leave the solving to the viewer, but what we end up with is a equals negative 4 over 3, b equals 23 over 9, alpha equals negative 2, and beta equals negative 4 over 3. And we have our particular solution, negative 4 over 3x plus 23 over 9, minus 2x times e to the 2x minus 4 over 3 e to the 2x. From here, we can determine the general solution by summing the particular and the homogeneous solution. To summarize, if the non-homogeneous term of a second-order linear differential equation with constant coefficients is a sum of functions that all meet the right criteria, we can still use the method of undetermined coefficients by determining the general particular solution for each of the terms and adding them together to generate our particular solution to the whole differential equation.